A remarkable archaeological discovery is reshaping our understanding of early human societies. Researchers have uncovered massive 7,000-year-old stone structures scattered across the deserts of the Arabian Peninsula. These ancient formations, known as mustatils, have been found in large numbers, particularly near the Nefud Desert. First identified through satellite imagery in 2017, hundreds of these structures are now known to exist, suggesting a widespread cultural practice. At first glance, the mustatils appear simple in design. Each structure consists of two large stone platforms connected by long, narrow walls. These walls sometimes stretch more than 600 meters in length. The walls themselves are relatively low. Unusually, there are no visible entrances. This raises immediate questions about their purpose, especially given their scale. Excavations have revealed very few signs of daily life at these sites. Researchers found no clear evidence of tools or storage. This suggests these structures were not used for practical purposes like shelter, farming, or water storage. Instead, their consistent design points to a shared idea or tradition among ancient communities. Dating analysis shows that these structures were built around 7,000 years ago, during a greener era. This period, known as the African Humid Period, supported grasslands across areas that are now desert. However, this climate began to shift and the region gradually became more arid. The timing suggests they were constructed during a period of environmental transition, when groups were adapting. While the structures don't reveal survival strategies, they may reflect how communities responded socially to these shifts. Further clues come from what was found inside. Archaeologists discovered collections of animal bones, including domesticated cattle. In certain cases, stones with geometric patterns were placed in prominent positions, indicating intentional design. These findings have led researchers to believe that the mustatils were likely used for ritual or ceremonial purposes. They may have been gathering places for shared activities, possibly including feasting or symbolic practices. Another important aspect is the effort required. Constructing structures of this size would have required massive coordination. This suggests that the act of building itself may have played a role in strengthening social bonds. The building process helped reinforce group identity, showing these societies were more organized than we believed. This discovery highlights how much of human history still remains hidden, even in places that have been in plain sight for thousands of years. Welcome to Tech Exploria. A rare and fascinating discovery deep beneath the Pacific Ocean is offering new insight into how our planet works far below the surface. Japanese scientists have uncovered an unusual type of hidden volcano near Minamitorishima Island, within an ancient section of the Pacific Plate. Believed to be around 3 million years old, this discovery is significant because it belongs to a rare category known as Petit-spot volcanism. Petit-spot volcanism is a type of volcanic activity that does not follow the typical patterns seen in most volcanoes across the globe. Unlike conventional volcanoes that form at tectonic boundaries or hotspots, Petit-spot volcanoes develop due to the bending of oceanic plates. As these massive plates begin to curve and sink into the Earth's mantle, small stress fractures can open up in the crust. These fractures allow magma from deep within the planet to rise and create small volcanic structures directly on the seafloor. The discovery began with detailed seafloor mapping conducted by the Japan Coast Guard, revealing an unusual formation. This formation did not match any known geological features in the region, prompting an even deeper investigation. Researchers turned to the advanced deep-sea submersible Shinkai 6500 to get a closer look at this mysterious site. Capable of diving to depths of up to 6,500 meters, the submersible allowed researchers to directly observe the site. Direct observation was critical. The scientists were able to see the structures and collect rock samples from the floor. These samples confirmed that the structure was indeed volcanic, providing solid evidence of this rare geological phenomenon. Scientists explain that Petit-spot volcanoes form when stress builds up in a bending tectonic plate, creating pathways. This allows magma to escape from the asthenosphere, a region beneath the crust that plays a key role in plate movement. This magma carries unique chemical signatures, offering valuable clues about the composition and behavior of the Earth's interior. These formations are important because they provide direct access to processes that are otherwise extremely difficult to study. While most info comes from indirect data, Petit-spot volcanoes act like natural windows into the deep layers of the mantle. This discovery helps expand our understanding of how tectonic plates interact with the mantle and how magma is transported. It also raises the possibility that many more of these hidden volcanoes exist, waiting to be discovered in remote regions. The findings have been published in a scientific journal, reinforcing the importance of combining advanced mapping with direct exploration. Overall, this highlights the complexity of Earth's internal systems and shows how much of our planet remains unexplored. As technology improves, we will uncover even more hidden features, reshaping our understanding of the forces that shape our world.